When I received the list of participants in this course and realized that I had been asked to speak to philosophical colleagues, I thought, after some hesitation and consolation, that you would probably prefer me to speak about those problems which interest me most, and about those developments with which I am most intimately acquainted. I therefore decided to do what I have never done before, to give you a report on my own work in the philosophy of science, since the autumn 1919 when I first began to grapple with the problem. When should a theory be ranked as scientific, or is there a criterion for the scientific character or status of a theory? The problem which troubled me at the time was neither when is a theory true, nor when is a theory acceptable. My problem was different. I wished to distinguish between science and pseudoscience, knowing very well that science often errs, and that pseudoscience may happen to stumble on the truth. I knew, of course, the most widely accepted answer to my problem, that science is distinguished from pseudoscience, or from metaphysics, by its empirical method, which is essentially inductive, proceeding from observation or experiment. But this did not satisfy me. On the contrary, I often formulated my problem as one of distinguishing between a genuinely empirical method and a non-empirical, or even pseudo-empirical method. That is to say, a method which, although it appeals to observation and experiment, nevertheless does not come up to scientific standards. The latter method may be exemplified by astrology, with its stupendous mass of empirical evidence based on observation, on horoscopes, and on biographies. But it was not the example of astrology which led me to my problem. I should perhaps briefly describe the atmosphere in which my problem arose, and the examples by which it was stimulated. After the collapse of the Austrian Empire, there had been a revolution in Austria. The air was full of revolutionary slogans and ideas, and new and often wild theories. Among the theories which interested me, Einstein's theory of relativity was no doubt by far the most important. The three other were Marx's theory of history, Freud's psychoanalysis, and Alfred Adler's so-called individual psychology. There was a lot of popular nonsense talked about these theories, and especially about relativity, as still happens today. But I was fortunate in those who introduced me to the study of this theory. We all, the small circle of students to which I belong, were thrilled with the result of Eddington's eclipse observations, which in 1919 brought the first important confirmation of Einstein's theory of gravitation. It was a great experience for us, and one which had a lasting influence on my intellectual development. The three other theories I have mentioned were also widely discussed among students at the time. I myself happened to come into personal contact with Alfred Adler, and even to cooperate with him in his social work among the children and young people in the working-class districts of Vienna, where he had established social guidance clinics. It was the summer of 1919 that I began to feel more and more dissatisfied with these three theories, the Marxist theory of history, psychoanalysis, and individual psychology, and I began to feel dubious about their claims to scientific status. My problem, perhaps, first took the simple form. What is wrong with Marxism, psychoanalysis, and individual psychology? Why are they so different from physical theories, from Newton's theory, and especially from the theory of relativity? To make this contrast clear, I should explain that few of us at the time would have said that we believed in the truth of Einstein's theory of gravitation. This shows that it was not my doubting the truth of those three other theories which bothered me, but something else. Yet neither was it that I nearly felt mathematical physics to be more exact than sociological or psychological type of theory. Thus what worried me was neither the problem of truth, at that stage at least, nor the problem of exactness or measurability. It was rather that I felt that these other three theories, though posing as science, had in fact more in common with primitive myths than with science, that they resembled astrology rather than astronomy. I found that those of my friends who were admirers of Marx, Freud, and Adler were impressed by a number of points common to these theories, and especially by their apparent explanatory power. These theories appear to be able to explain practically everything that happened within the fields to which they referred. The study of any of them seemed to have the effect of an intellectual conversion or revelation, open your eyes to a new truth hidden from those not yet initiated. Once your eyes were thus opened, you saw confirmed instances everywhere. The world was full of verifications of the theory. Whatever happened always confirmed it. Thus its truth appeared manifest, and unbelievers were clearly people who did not want to see the manifest truth, who refused to see it, either because it was against their class interest, or because of their repressions which were still unanalyzed and crying aloud for treatment. The most characteristic element in this situation seemed to me the incessant stream of confirmations, of observations which verified the theories in question, and this point was constantly emphasized by their adherents. A Marxist could not open a newspaper without finding on every page confirming evidence for his interpretation of history, not only in the news but also in its presentation, which revealed the class bias of the paper, and especially, of course, what the paper did not say. The Freudian analysts emphasized that their theories were constantly verified by their clinical observations. As for Adler, I was much impressed by a personal experience. Once in 1919, I reported to him a case which to me did not seem particularly Adlerian, but which he found no difficulty in analyzing in terms of his theory of inferiority feelings, although he had not even seen the child. Slightly shocked, I asked him how he could be so sure. "Because of my thousand-fold experience," he replied, whereupon I could not help saying, "And with this new case, I suppose, your experience has become 1,001-fold." What I had in mind was that his previous observations may not have been much sounder than his new one, that each in its turn had been interpreted in the light of previous experience, and at the same time counted as additional confirmation. What, I asked myself, did it confirm? No more than that a case could be interpreted in light of a theory. But this meant very little, I reflected, since every conceivable case could be interpreted in the light of Adler's theory, or equally of Freud's. I may illustrate this by two very different examples of human behavior. That of a man who pushes a child into the water with the intention of drowning it, and that of a man who sacrifices his life in an attempt to save the child. Each of these two cases can be explained with equal ease in Freudian and Adlerian terms. According to Freud, the first man suffered from repression, say of some component of his Oedipus complex, while the second man had achieved sublimation. According to Adler, the first man suffered from feelings of inferiority, producing perhaps the need to prove to himself that he dared to commit some crime. And so did the second man, whose need was to prove to himself that he dared to rescue the child. I could not think of any human behavior which could not be interpreted in terms of either theory. It was precisely this fact, that they always fitted, that they were always confirmed, which in the eyes of their admirers constitute the strongest argument in favor of these theories. It began to dawn on me that this strength was in fact their weakness. With Einstein's theory, the situation was strikingly different. Take one typical instance, Einstein's prediction, just then confirmed by the finding of Eddington's expedition. Einstein's gravitational theory had led to the result that light must be attracted by heavy bodies, such as the sun, precisely as material bodies were attracted. As a consequence, it could be calculated that light from a distant fixed star, whose apparent position was close to the sun, would reach the Earth from such a direction that the star would seem to be slightly shifted away from the sun. Or in other words, that stars close to the sun would look as if they had moved a little away from the sun. This is a thing which cannot normally be observed, since such stars are rendered invisible in daytime by the sun's overwhelming brightness. But during an eclipse it is possible to take photographs of them. If the same constellation is photographed at night, one can measure the distance on the two photographs, and check the predicted effect. Now the impressive thing about this case is the risk involved in a prediction of this kind. If observation shows that the predicted effect is definitely absent, then the theory is simply refuted. The theory is incompatible with certain possible results of observation, in fact with results which everybody before Einstein would have expected. This is quite different from the situation I have previously described, when it turned out that the theories in question were compatible with most divergent human behavior. so that it was practically impossible to describe any human behavior that might not be claimed to be a verification of these theories. These considerations led me, in the winter of 1919-20, to conclusions which I may now reformulate as follows. 1. It is easy to obtain confirmations or verifications for nearly every theory, if we look for confirmations. 2. Confirmations should count only if they are the result of risky predictions. That is to say, if, unenlightened by the theory in question, we should have expected an event which was incompatible with the theory, an event which would have refuted the theory. 3. Every good scientific theory is a prohibition. It forbids certain things to happen. The more a theory forbids, the better it is. 4. A theory which is not refutable by any conceivable event is non-scientific. Irrefutability is not a virtue of a theory, as people often think, but a vice. 5. Every genuine test of a theory is an attempt to falsify it or refute it. Testability is falsifiability. But there are degrees of testability. Some theories are more testable, more exposed to refutation than others. They take, as it were, greater risks. 6. Confirming evidence should not count except when it is the result of a genuine test of the theory, and this means that it can be presented as a serious but unsuccessful attempt to falsify the theory. 7. Some genuinely testable theories, when found to be false, are still upheld by their admirers. For example, by introducing ad hoc some auxiliary assumption, or by reinterpreting the theory ad hoc in such a way that it escapes refutation. Such a procedure is always possible, but it rescues the theory from refutation only at the price of destroying, or at least lowering, its scientific status. I later described such a rescuing operation as a conventionalist twist, or a conventionalist stratagem. One can sum up all this by saying that the criterion of the scientific status of a theory is its falsifiability, or refutability, or testability. I may perhaps exemplify this with the help of the various theories so far mentioned. Einstein's theory of gravitation clearly satisfied the criterion of falsifiability. Even if our measuring instruments at the time did not allow us to pronounce on the results of the test with complete assurance, there was clearly a possibility of refuting the theory. Astrology did not pass the test. Astrologers were greatly impressed and misled by what they believed to be confirming evidence. Moreover, by making their interpretations and prophecies sufficiently vague, they were able to explain away anything that might have been a refutation of the theory had the theory and the prophecies been more precise. In order to escape falsification, they destroyed the testability of their theory. It is a typical soothsayer's trick to predict things so vaguely that the predictions can hardly fail, that they become irrefutable. The Marxist theory of history, in spite of the serious efforts of some of its founders and followers, ultimately adopted this soothsaying practice. In some of its earlier formulations, for example in Marx's analysis of the character of the coming social revolution, their predictions were testable and in fact falsified. Yet instead of accepting the refutations, the followers of Marx reinterpreted both the theory and the evidence in order to make them agree. In this way they rescued the theory from refutation, but they did so at the price of adopting a vice which made it irrefutable. Thus they gave a conventionalist twist to the theory, and by this stratagem they destroyed its much advertised claim to scientific status. The two psychoanalytic theories were in a different class. They were simply non-testable, irrefutable. There was no conceivable human behavior which could contradict them. This does not mean that Freud and Adler were not seeing certain things correctly. I personally do not doubt that much of what they say is of considerable importance, and may well play its part one day in a psychological science which is testable. But it does mean that those clinical observations which analysts naively believe confirm their theory cannot do this any more than the daily confirmations which astrologers find in their practice. And as for Freud's epic of the ego, the superego, and the id, no substantially stronger claims to scientific status can be made for it than for Homer's collected stories from Olympus. These theories describe some facts, but in the manner of myths. They contain most interesting psychological suggestions, but not in a testable form. At the same time, I realized that such myths may be developed and become testable, that historically speaking all, or very nearly all, scientific theories originate from myths, and that a myth may contain important anticipations of scientific theories. Examples are Empedocles' theory of evolution by trial and error, or Parmenides' myth of the unchanging block universe, in which nothing ever happens and which, if we add another dimension, becomes Einstein's block universe, in which, too, nothing ever happens since everything is, four-dimensionally speaking, determined and laid down from the beginning. I thus felt that if a theory is found to be non-scientific or metaphysical, as we might say, it is not thereby found to be unimportant or insignificant or meaningless or nonsensical, but it cannot claim to be backed by empirical evidence in the scientific sense, although it may easily be in the result of observation. There were a great many other theories of this pre-scientific or pseudo-scientific character, some of them unfortunately as influential as the Marxist interpretation of history. For example, the racialist interpretation of history, another of those impressive and all-explanatory theories which act upon weak minds like revelations. Thus the problem which I tried to solve by proposing the criterion of falsifiability was neither a problem of meaningfulness or significance, nor a problem of truth or acceptability. It was the problem of drawing a line, as well as this can be done, between the statements, or systems of statements, of the empirical sciences and all other statement, whether they are of a religious or a metaphysical character, or simply pseudo-scientific. Years later, it must have been in 1929, I called this first problem of mine the problem of demarcation. The criterion of falsifiability is a solution to this problem of demarcation, for it says that statements or systems of statements, in order to be ranked as scientific, must be capable of conflicting with possible or conceivable observations. Thanks for watching.